First we can see what is an adder. So adder is an electronic circuit. It performs the addition of numbers. When we say numbers, it is the addition of binary numbers. The adders are commonly used in the ALU of a computer. Also, it is used in most of the electronic devices. There are two types of adders. One is called the half adder and another one is called the full adder. In the case of a half adder, we use it for adding two binary bits. In the case of a full adder, we use it for the addition of 3 bits. 3 bits means it is the binary digits. Okay. So half adder we use for the addition of 2 bits and full adder we use the addition of 3 bits. Okay. First we can see the details of a half adder. I told you half adder is an electronic circuit which is used for the addition of 2 binary numbers or 2 binary digits. Right? It performs the addition of 2 binary bits or 2 bits. When we perform the addition of 2 bits, it can produce a sum and a carry. Right? On this page, you are seeing the box diagram of a half adder. So here in this page, you can see the box diagram of a half adder. Please note that the sum is represented as A XOR B and carry is represented as A and B or A dot B. Here you can see the truth table for a half adder. So A and B are the 2 binary digits. So we got a column for carry and we got a column for sum. When A is equal to 0 and B is equal to 0, when we perform the addition of 0 plus 0, carry becomes 0 and sum becomes 0. And when we perform the addition of A is equal to 0 and B is equal to 1, we may get carry as 0 and sum is equal to 1. Again, when A is equal to 1 and B is equal to 0, we are getting carry as 0 and sum as 1 because 1 plus 0 is equal to 1. There is no carry. So it is carry is 0, sum is equal to 1. Then when we add A is equal to 1 and B is equal to 1, when we add A is equal to 1 and B is equal to 1, we are getting 1 plus 1. So it is a binary digits. So in binary digits we use only 0 and 1, right? 1 plus 1. We know the decimal way 1 plus 1 is equal to 2. So similarly 1 plus 1, the binary way it is 1 plus 1 is equal to 2. In 2 in binary it is 1 0. When we have 1 plus 1 is equal to 1 0, which means we can represent 0 in the sum column and 1 in the carry column. Okay. Here we have the logic gate diagram of a half adder. If you consider the truth table of a half adder, you can see that the sum values are equal to the XOR values. Let me repeat again. The sum values, the values in the sum column is equal to A XOR B. So that is why I am representing sum is equal to A XOR B. And when you consider the carry column values are equal to the values of A dot B. So the logic gate diagram of a half adder looks like this. On the screen you can see that A and B are the two input lines. The sum produces A XOR B and carry produces A dot B. Okay. So Full adder is an electronic circuit which performs the addition of 3 binary bits. So let that 3 binary bits are A, B and C. So when we add these 3 binary bits, it can produce a sum and it can produce a carry. Okay. Here you can see the truth table for a half adder. Here A, B and C are the 3 input binary bits, right? So when there are 3 values, there will be 8 possible combination of binary bits on the truth table, and there is a carry column and there is a sum column. When we add 0 plus 0 plus 0, that is A equal to 0, B is equal to 0 and C is equal to 0, we will be getting carry as 0 and sum as 0. Next one is A is 0, B is equal to 0, C is equal to 1, which produce 0 plus 0 plus 1. That is, we are getting carry as 0 and sum is equal to 1. Next one is A is equal to 0, B is equal to 1 and C is equal to 0. So this also produce carry as 0, sum is equal to 1. Our next values are A is equal to 0, B is equal to 1 and C is equal to 1. When we perform 0 plus 1 plus 1, 0 plus 1 is equal to 1, 1 plus 1, it is equal to 1 0. So when it is 1 0, we have to put the 0 in the sum and 1 in the carry. Okay. Then the next one is A is equal to 1, B is equal to 0 and C is equal to 0. When A is equal to 1, B is equal to 0 and C is equal to 0, we will be getting carry as 0, sum is equal to 1. Next one, A is equal to 1, B is equal to 0 and C is equal to 1. So A plus B, so A plus B means 1 plus 0 plus C, that is 1 plus 0 equal to 1 plus 1, which produces 1 0. So we can represent 0 in the sum, 1 in the carry. Again, A is equal to 1, B is equal to 1 and C is equal to 0. So 1 plus 1, it produces 1 0 plus 0, that is 1 0. Sum is equal to 0 and carry is 1. So the last case where A is equal to 1, B is equal to 1 and C also 1. So when we perform A plus B plus C, that is 1 plus 1, which produces 1 0 plus 1, it produces 1 0 plus 1, it is 1 1. So in the sum also it is 1 and carry also it is 1. Okay. Here you can see the logic gate diagram of a full adder. So 3 binary bits are there, namely X, Y, Z. So the sum column, it is sum S is equal to X XOR Y XOR Z. And the carry we are representing as the sum of an OR gate. We are using as a sum term, right? So that is XY plus YZ plus ZX. Right? So please understand this logic gate diagram. It is very important, where sum is equal to X XOR Y XOR Z and carry is equal to XY plus YZ plus ZX.